going to start with area and perimeter. I'm going to give everybody 10 seconds to take a screenshot of these formulae for some of these 2D shapes that we have. I'm going to add one more in here. The area of a kite. Area of a kite is going to be diagonal 1 times diagonal 2 divided by 2. I'd like you guys to take a screenshot of that. You've got 10 seconds, and then we're going to get started on today's lesson. All right, okay, I think that's plenty of time. Everybody should have been able to take a screenshot by now. Okay, let's have a look at our first challenge over here. All right, our first challenge says, find the area and perimeter of the following shapes. Now, I want you guys to be very careful. They want both the area and the perimeter. So don't just calculate for the one. You need to calculate for both. And when you're done, as always, pop your favorite emoji into the chat. All right. You guys have, I'll give you guys, let's see if we can do 8 minutes, because there are 4 questions and you need 2 calculations for each. I'll give you guys 2 minutes per question, 8 minutes. All right, go for it. Fatu, my goodness, hello, where have you been? You just disappeared on us for a long while. How are you? Fatu's been on long vacation. We see. Oh, okay, we see you. Well, welcome back anyway. It's good to have you back with us. Oh, that's a first. It must be so shocking to come into class and find that Offense is actually named Offense today. That's so weird. Yes, no much we can. Four more minutes, guys. Remember to pop your favorite emoji in the chat when you're done. Phones are always first one out the gate. Nice one, Asbonge. I know. 2 more minutes, guys. True. Sorry, offense. All right. Okay, that's time. Let's have a look at some of these questions over here. Right, let's start with the area of our triangle. We know that the area of a triangle is going to be half of the base times the height, which is going to be half of 12 times 5, which is going to be 30 centimeters squared. Okay, the area of our rectangle is going to be length times breadth, which is going to be 15 times 5. That is 75 centimeters squared. The area of our circle is pi radius squared, which is the same as 9 pi. 9 pi, but if you also gave it to me with 2 decimal places, that's perfectly fine. You can also write the answer as 28.27 millimeters squared. And over here, remember the area of a kite is diagonal 1, which is 34 millimeters, times diagonal 2, which is 12 millimeters. Okay, and we're going to divide those two by 2. Divided by 2 should give us 204 millimeters. All right. For your area calculations, 1, 2, 3, 4, tell me, how much did you get out of 4 for your area calculations? Pop your answer in the chat, peeps. Oh, sorry, Hope, it's not. It's 75. Sorry, my sweetie. I didn't finish it off. Sorry, 75 centimeters squared. Sorry. Okay, give me a number out of 4, guys. How much did we get? Sorry, Hope. Excellent, excellent stuff. All right, cool beans. Okay, let's talk about the perimeter of each of these. Right, now we know that when we're calculating for the perimeter, we are actually calculating the outer edge of our shape. No worries, Pascal, welcome. Right, so when we calculate for the outer edge of this first question that we have over here, we're going to note that we're missing our longest side. We're missing the hypotenuse side. So what do we need to do in order to find that long side, guys? What do we need to use? Correct, part 2. That's it. Excellent. We're going to use Python. All right, so we're going to go 5 squared plus 12 squared is equal to h squared, the hypotenuse squared. And then we need to write Python in brackets because we're using his theorem, right? 25 plus 144 is 169 is equal to h squared. So the hypotenuse should be equal to 13 centimeters, right? So this side over here is 13 centimeters. Now, if we want to calculate for the perimeter, we're going to add all of those together. 13 plus 12 plus 5 is equal to 30 centimeters. That's the answer we want. Well done, Pascal, correct. The perimeter over here, the perimeter of a rectangle is just 2 multiplied by the length plus breadth. Plus breadth, that's going to give me 2 multiplied by 15 plus 5, which is going to give me 30 centimeters. Right. Now, calculate for the perimeter of my circle. What is called the perimeter of the circle? Who remembers? What is the perimeter of the circle actually called? Anybody? Correct, Hope. Absolutely, 100%. It's called the circumference. Good. The perimeter of a circle is called a circumference. The circumference of the circle is calculated as 2 times pi times the radius. Right. So we can then write 2 times pi times 3, which is the same as 6 pi. 6 pi, or you can also give the answer as 18.85 millimeters. Okay, now for the diagonal or for the heights, this is going to be quite easy because they've given us all the information we need. If this side is equal to 19 millimeters, we know that that side will also be equal to 19 millimeters because of those 2 lines. Those 2 lines tell us that these 2 sides are equal to each other. And if this side is 21 millimeters, this side is also 21 millimeters. We can calculate for the perimeter of this side. Perimeter is equal to 2 of 19 plus 21, which should give us 80 millimeters. I'm going to ask again. This time, give me a mark out of 5. 1 mark for getting Pythagoras, 1 mark for calculating the perimeter. Perimeter of a rectangle, perimeter of a circle, and the perimeter of a cup. How much did we get out of 5 for this exercise? Sunzo got 5, well done. What about the rest of you guys? How much did we get? Okay, I'm seeing quite a few 4s. For those of you who did get 4, do we know why we got 4? Are we aware of our mistakes? Please do let me know if we know why we got the mark. The area of D again. All right, no problem, Karika. So the thing is, the formula, because this is a kite. Okay, this is a kite. I know it looks like a rhombus, but it's a kite. The formula for a kite is the diagonal 1 times the diagonal 2 divided by 2. So they've given us the dimensions for the diagonals. They tell us that diagonal 1 is 34 and diagonal 2 is 12. So the formula tells us that we need to take diagonal 1, which is 34, multiplied by diagonal 2, which is 12, divided by 2. And that's how ma'am got 240 millimeters squared as an answer. I need you and Hope to give me a thumbs up. This makes sense. Yeah. Excellent. Excellent. All right. Okay. Can we step it up a notch? Right. Because this at the moment is still child's play. So we need to step it up. Are we all ready? Oh, you're supposed to say, yes, ma'am. I'm done for the challenge. Let's go. Let's do this. No? No? Oh, no. Okay. All right. Okay. So we're going to skip this one quickly and we're going to come back to that. All right. So we are going to be finding the area of composite shapes. Okay. We're going to find the area of composite shapes. So we already know what the area of each of these is. We just need to put it in a way that we're going to understand. All right, so I know that this is a circle, but it's not a full circle. What kind of circle do I have? If we're looking at A, what part of the circle do I actually have? So I'm sorry. I'm sorry for, yes, correct. We have a semicircle or half a circle. Now, if we're going to calculate for the area of this, we're just going to use the normal formula that we know for the area of the circle. We're going to, the area of the circle is pi times radius squared, but, okay. But because this is half a circle, we're just going to take the answer we have and multiply it by a half. And I know that somebody's going to ask me, ma'am, can we just divide by 2? Yes, we can. We can. But Pascal, multiplying by a half and dividing by 2 is the same thing. Okay. But there's a particular reason why Teacher Coco is asking you to multiply by a half instead of dividing by 2. Okay, it's going to give you the exact same answer. If you multiply by half or you divide by 2, you're going to get the exact same answer. Now, I'm not going to do this answer for you. I'm just going to ask you guys before we continue, what part, if we look at question B, what fraction of my circle is this part of B? What fraction of my circle? Sure, Patu, I see you're back with a bang, just like, killing it. That's it, Amber. Well done, Pascal. Good. So we're just going to calculate the area of a circle, but this time we're going to multiply by a quarter. Okay. We're going to do the exact same thing, guys. What about C? What portion of my circle is C? Correct. That's it. Correct. It is 3/4. Correct. It's 3/4. So we're going to do the exact same thing. We're going to take the area, and instead of just the area, we're going to take the area and multiply by 3/4. All right. When you're done with all 3 questions, guys, pop your favorite emoji in the chat. Correct, Akwando, 100%. The normal shape of a circle just multiplied by the fraction of whatever circle it is. Well done, Asbonge. Nice emoji now. Okay, Pascal, we'll see. I'm sure we've all done just perfectly fine. The question, it's not as difficult as it looks, I'll tell you guys. The questions are not as difficult as they look. All right, one more minute, then we'll get started. What in the world am I doing? Right. Okay, peeps, let's get started on these three questions. Now, remember, we're just calculating for the area as we normally would. So don't stress too much about trying to figure out a new formula. We're going to use the exact same formula that we have for area. Now, big problem in this first question over here. They've given us the diameter. They've given us D is equal to 42. Now, if my diameter is 42, what is my radius going to be equal to? Correct. Correct. Good. So I'm just going to say that my area is equal to pi times my radius, which is 21 all squared times a half. I'm just going to take that times a half, and I should get 692.7 meters squared. Not more than one decimal, guys, because the instructions do say correct for one decimal place. So you must give them one decimal place as well. All right. Okay. The next one, we're going to do the exact same thing, guys. Area is equal to pi times our radius, which is 75, pi times 75 squared times a quarter times 1/4, which is equal to 4,417.9 centimeters squared. Good. All right, well done, Pascal. See, Pascal, it's not as bad as we thought. Right. So the area of this one is going to be pi times 36 all squared times 3/4 times 3/4. The answer we should get here is 3053.6 millimeters squared. Give yourself a mark out of 3. 1, 2, 3. Tell me, how did we do, guys? Well done, Pascal. And here you were busy saying it's not make sure, but look at you now. Well done, Hope. Awesome stuff, Imelda and Funzo and Atahang. Funzo, what happened? Why 2 and not 3? Let me know, guys. How did we do? Okay. All right, peeps. Let's talk about question D, because D is a bit tricky, if we're being completely honest. Now, I don't check. There's nobody shaking, man. There's no shaking. We are not shaking. Relax. Okay. Those of you who don't TikTok, you won't understand what's happening. Right. Tatum has already given away the answer, but we need to understand where this particular answer comes from. Now, we've been given a portion of a circle, guys. We've been given a portion of a circle, right? And we need to figure out how much of a circle this actually is, right? And they've given us the degrees. Look at this. They've given us the degrees that make up the part of the circle that we have, 330 degrees. So how are we going to figure out what percentage or what fraction of my circle this is? Right? How many degrees are there in a full circle, guys? Correct, Nico. Excellent, Aquana. That's it, Amber. We know that there are 360 degrees in a full circle. So if I want to know what fraction of my full circle this is, I'm going to go 330 divided by 360. And that could give me the fraction that I'm looking for. And Tatum has already told us that 330 degrees of 360 is the same as 11 12. Okay. And that's going to be able to give us the answer we're looking for. Now, we're going to do the exact same thing, guys. We're not going to change anything at all. We're still going to calculate the area as we normally would, pi times radius squared. And this time we're just going to multiply it by 11 over 12. Yes, correct, Pascal. That's it. Let's think about this next one over here. Let's look at question E, because we're going to do both D and E just now. What fraction of my circle is this 240 degrees that they've given us over here? What fraction of my circle is it? Correct, it's 2/3. And we can figure that out by taking 240, dividing that by 360, so it can give me the fraction of my circle. So I'm going to do the exact same thing, guys. The area is equal to pi times radius squared multiplied by 2/3. Right. Okay, you guys have 2 minutes to answer these questions. Pop a thumbs up or a done in the chat when you are finished. And then we'll take it from there. It shouldn't take us too long. It should take you about 1 minute per question. So it's not even that deep. Sure, Pascal, that was super fast. Super fast. I know, right, Hope? I know. All right, that's plenty of time, guys. Remember, we're just doing some we're just plugging and playing into our calculator. We're not really doing much calculating, right? So we're going to say the area is equal to pi times 12 all squared times 11 over 12. Pi times 12 squared times 11 over 12 is equal to 414.7 meters squared. And for this last one over here, our area is going to equal to pi times 44 all squared times 2 over 3, which did give us equals squared, 3 is equal to 4,054.7 centimeters squared. And as Bonge and Pascal, who have forgot the units of measurement, we do not forget those. All right, 1 mark for that and 1 mark for that. Now, before we continue, I'm going to ask you guys on a scale of 1 to 10, 1 being, ma'am, I don't understand a single thing, and 10 being, I'm with you, ma'am, I got this, this is easy. Let me know how these first 5 questions have gone. How do you feel about this? So, that is even at a 15 out of 10. I like it. Now, where did that 0.4 go? Punzo, a 3. Relax, Pascal, it's not that hard. It's not that deep, I promise. Punzo, what's going on? Why are we at a 3? Where have we missed you? Where have we left you behind? Okay, that's fair. I understand. I just need to practice more. It does actually look very easy, because what we're going to be doing is looking at composite shapes, right? Okay, that's what's coming next. If we look at this question that we've got over here, guys, let's look at F very quickly. Let's take a look at F, right? I know that this particular shape that we're looking at F is made up of 2 different shapes. What are those 2 different shapes? If we look at F, what 2 shapes make up this? Correct, Nico? It's a rectangle. There is a rectangle, but I want you to be very specific about the other part. Rectangle and a what? Correct. That's it, Nico. Excellent. This shape over here is made up of a rectangle and a semicircle. Now, has the semicircle been added to the rectangle, or has it been taken away? Correct. Yes, Pascal, and pi what? Correct. Pi what? Yes. Okay. Good, Nico. You're getting the hang of this. They've given us. Okay, Atakan, have they added a piece of the circle, or have they added the semicircle, or have they taken away the semicircle from the rectangle? Okay, I'm not getting a response, but I'm going to assume Adlahan gets where I'm going with this. All right. So we know that they've taken away part of it. So what we're going to do is, if it was added, then it would look like that. Right. And then this part wouldn't exist. Let me show you. Like this. Okay. I hope I'm doing this justice. Okay. So hope if they had added it, this is what our shape would look like. Okay. But now we know that. Okay. But now we know that they haven't added it, they have taken it away, right? So if they've taken it away, are we going to then add or minus? Are we going to plus or are we going to minus from the rectangle? Correct. We're going to minus. So we're going to find the area of our rectangle. And then we're going to minus the area of our half circle. Half circle. Not full circle, only semicircle. Right. Now, there are a couple of things that we need in order to calculate for the area of a rectangle and a circle. We know that the area of a rectangle is going to be length times breadth, which is nice enough because we have that stuff. And then we're going to minus the area of a circle, which is pi times radius squared times a half, because it's still a half circle. Right. We're missing some very important things. What are we missing? Yes, Patu.
Ma'am, we're missing the radius for our circle.
Beautiful. Correct. So how are we going to find this radius? Let's think about it.
Ma'am, we're going to say 36 minus 24, which will give us like 12.
Good. Okay, where did you get this 24
from? Because up there, like at the top line, it says 12 centimeters, and then it says the other side is equal. So meaning it's going to be 12 plus 12, which is like 24.
Good, good. So the remainder of our circle over here will be 12 centimeters. Agreed. It's 12 centimeters, yes, but that still doesn't help. That doesn't solve our radius problem.
We're going to divide the 12 by 2.
Correct. Correct. Excellent. So we know that if our diameter is 12, our radius will be
6.
Beautifully done. 100%. Okay. Thank you, Pat. I feel like you've given them enough answers now. They must go off and do it themselves. Okay, everybody. Patu has given us the relevant information we need. We have our length and our breadth. We now have our radius of our circle. So calculate for the area. Yes, the area. Calculate for the area of our composite. Okay, you guys have 1 minute. I don't think it's that deep anymore. Excuse me. Funzo says, ma'am, where did you get the radius of 6? All right, Funzo, let's think about this. In the drawing, right, we know that we have a length of 36, right? We've got a length of 36 centimeters, which means because it's a rectangle, that means this side is also 36 centimeters, right? Now they tell us that this portion over here, from here to here, is 12 centimeters. But they also give us this line, these two lines. And we know that those two lines mean that the lengths of those two things are equal to each other. So we know that this is also 12 centimeters, right? So if the whole side is equal to 36 centimeters, and I've got 12 and 12 over here, that's 24. That means from this part of my circle to that part of my circle is also going to be 12 centimeters. But that length on a half circle is the diameter. And we know that the diameter is 2 times the radius. So that means that my radius has to be half of that diameter, which is, okay, let me know if that makes sense, Funzo. All right. So we're going to go 36 times 16, good, minus pi times 6 all squared times a half. All right, and it shouldn't take anybody that long because you're going to punch this into your calculator exactly the way that you see it. All right. Times a half, and you could go to straight to the answer, which would be 519.5 centimeters squared. Landile beach also He DM'd me the answer like years ago. Y'all have been sleeping on this question. Lundile is done. All right, let's have a look at this next one. All right, if we look at question G, look at question G, guys. This particular shape is made up of two shapes. What two shapes do we have here? Correct. No, not a cone. It's not going to be a cone. Nico, be careful. Okay, correct. Tabo and Pascal, good. We know that we've got a semicircle and a triangle. And Nico, the reason I'm saying that it's not a cone is because cones are 3D. And at the moment, when we calculate for area, we can only ever calculate for the area of 2D shapes. We cannot calculate the area of 3D shapes. Right. We only calculate the area of 3D shapes. No problem. It's not even that big a deal. I'm just being very OCD about it. Okay, cool. Now, there are a couple of things that we need to establish because we know that we're going to have to calculate for the area of a half a circle and the area of a triangle. Now, has the triangle or the circle been added or taken away in this particular case? Has it been added or taken away? Correct, it's been added. So we're going to take our two areas once we've calculated for them, and we're going to add them together, right? The area of a circle, again, the area of a circle is pi times radius squared times a half because it's half a circle. Then we're going to need to calculate for the area of a triangle, which is half the breadth times the height. Now we're missing, sorry, half the base times the height. We're missing a lot of things. We're missing a lot of things. First, we don't have a radius. Also, we don't have a base. And also, we don't have a height. So we need to figure out all of these things, right? Anybody, any brave volunteer want to help us out? How are we going to find the radius, the base, and the height of my circle? Sorry, the radius of my circle, the base, and the height of my triangle. Part two, where are we going to start?
Ma'am, won't the base be equal to the diameter of the semicircle?
100%, correct. Our base is going to equal to 40 centimeters. Let's fill in the other gap. What else do we know?
And then, ma'am, our height is going to be 64 minus 20, I think.
How did we get it?
Ma'am, half of the diameter, which is like, I did it like vertically, the height. I said the radius.
100% correct, yes.
Yeah.
Good.
So I
So
got
we know
like
that
44.
if the radius, what is the radius? What is our radius?
It's half, the radius is 20.
Correct. So we know that if the distance from the center to there is 20, the distance in height from here all the way to the top of my circle will also be 20, which is good. You've given us
Yes,
the
ma'am.
radius as well. So the height of my triangle will then have to be how much?
44.
Beautiful, good, because from here to there is 64, which means from here to there must be
44.
Top
Thank you.
mark, 100%. Wow. All right, give me a thumbs up if everybody understands what Patu has just explained. Yo, Lwandile is just like killing it. Lwandile is already answered. We're already done here. Right. Give me a thumbs up, guys, if we understand where Patu got all of these values from for the base, the radius, and the height. Okay, all right. With all that being said, I'm going to give you guys a chance to calculate for G. If you already have, please go ahead and calculate for H. And Lwandile, of course, you can put your hand up and we can talk about H as we go. All right, you guys have let's calculate for G. If you've already done it, go ahead and calculate for H as well. All right, peeps, that's time up. All right, so we can do this. Remember, guys, you can do this all in one fell swoop, one fell calculation. So we're going to say the area of the composite shape is going to be pi times 20 all squared times a half plus half of 40 times 44. And the answer we should get out is 1,508,3 centimeters squared. Okay, well done if you managed to get that answer. Okay, for the sake of time, I'm going to ask Lwandile, are you there? You want to unmute for me and help me with this next question? Hi, Lwandile. No, don't mute and unmute. Don't unmute and mute again. Mute, unmute.
Ma'am, it's his phone, ma'am.
Oh, no, don't blame the phone. Don't blame the phone. Okay. All right. Let's talk about the strategy for this next one. Okay. So what were you thinking we could do, London, in this particular question? Yeah.
I'd first do the two semicircles and find out the,
all right.
the area for the two semicircles. Then I'd move on to the rectangle. Then I'll minus at the end.
Beautiful. Good. Absolutely, we can do that. All right. We know that we have two semicircles, Lwandile. Right. We have two semicircles, a semicircle and a semicircle. So if I'm really calculating the area that's been taken out, what should I actually be calculating for? The area of? Is it really two semicircles? No. What would I be calculating for the area of?
Oh, pardon?
Instead of calculating for the area of two semicircles, what can I calculate the area of?
The rectangle.
We can do the rectangle, yes, but instead of just taking a half a circle and then calculating the area of a half a circle, what can we do? What can we calculate for the area of?
Just calculate an area of the full circle.
Correct. That's it. The area of the full circle. Good. So we know to calculate for this, we're going to take the area of the rectangle minus the area of the full circle. Excellent. You want to do this for me? Okay. We're going to go area is equal to, give me the area of the rectangle. What's that going to be?
Area is going to be like length times breadth, which is 20 times 10, which is equal to
20 times 10. Good. Minus, then we know that we're going to need pi r squared. What is our radius, by the way?
5.
Beautiful. Get this 5. Where did this 5 come from?
Go 5. The area is equal to 78,6.
Okay, cool. I want you to tell me, how did you get that the radius is 5?
Pi, open brackets 5, close brackets 2. And I punch in the calculator.
Where did you get the 5? Where did the 5 come from?
It's the radius.
How did you find the radius?
Since 10 was given, which is the diameter, I divided the 10 by 2, which gave me the radius.
That's the answer I was looking for, 100%. Yes. So I want you to explain where the radius comes from. Good. We know that the diameter was well done. All right. I want you to give me a full answer for everything altogether. All right. So your rectangle minus your circle is going to give us how much?
The answer is 121,4 centimeters squared.
Not comma 4, round up properly. 121 comma
5.
Correct, comma 5, because it's comma 46. So we must round up. So 121,5 centimeters. Well done.
Yes,
well done. I feel like, okay, I know I feel like it feels like I'm being pedantic, but if you just tell me the radius is 5, some people aren't going to know where you got it. And that's why I'm asking you to explain. But I 100% knew that you knew where the answer was coming.
Yes, ma'am.
Okay, well done, London. Very nicely done. Very nicely done. Okay. Hope says, what pedantic? I'll spell it for you. It's called Pededantic. Called pedantic. You can Google it, but it basically means I'm nitpicky. Okay, like I nitpick all the tiny things, like the small things are important. So you must give me every single tiny little detail. Yes, correct. Yes. All right. That's where we're going to stop for today's lesson because we are going to run out of time. But I want to encourage you guys to try I on your own. I want you guys to take a screenshot of I, go and try it, and then as normal, as usual, because if you know anything about Teacher Coco, is that we're going to have to do a little bit extra.